4 is on circumference and arc length. So we all know how to find the circumference of a circle. Do you guys remember the formula? That's the key. If you know the formula, you're going to be good in this section. So circumference is what? Pi times diameter, or 2 times pi times r, because 2r is the diameter, right? So number 1, it says find the circumference of a circle with a diameter of 18 inches. Really easy. If I do my pi times diameter, it's pi times 18. So it's just 18 pi. Done. What would my units be? Yeah, it's still just inches, right? It's not like inches squared or anything. It's inches. All right, find the radius of a circle if you have a circumference of 67 meters. So circumference is equal to 2 times pi times r. So if I have a circumference of 67 and I want to solve for my radius, I have to get rid of this 2 in the pi. So we divide it out. So we do 67 divided by 2 pi. Now I do want you guys to do this on your calculator because a lot of people do this on their calculator incorrectly. So go ahead and do 67 divided by 2 pi on your calculator. And tell me what you get. 105, did you get that? Is that what you said? Yep, it's not 105. Sad story. So it should actually be 10.663. So remember how I talked about how you guys are my future bridge builders and so on? Like, we need to know how to do things like this, so be really careful. So on your calculator, what you're doing is when you do 67 divided by 2 pi, since we're dividing by the entire 2 pi altogether, we have to put parentheses around it. Okay, otherwise you're going to get this question wrong. You're going to get 105.24, which is nowhere close to 10.663. So if you're launching a space shuttle into space and you use that, you divide by pi incorrectly. Don't do that. Don't do that. Okay, so you guys all have future jobs. I don't know what they're going to be. All right, so yeah, it should be 10.663. Do we see that? Another thing you could do is you could divide by the 2 first, and then find that answer, and then divide by pi second. So you could do that as well. All right, so arc length. So it says a portion of the circumference of a circle. Okay, so the arc length corollary says in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio. I'm actually not going to use this ratio thing. I'm going to show you another way. So here's what I want you to guys to consider. Let's say that the circumference of the circle, let's say this is 10 inches. What would the circumference of a circle that looks like this be? If I had 10 inches for my radius. It'd be 20 pi, right? Do we have that? I picked an easy number for you. What if I wanted this length from here to here? That I drew in red. What would the length of the curve from here around be? 10 pi, right. So Austin, how did you get that? What did you think? Because it's half the circumference, right? Do we all see that that length is half the circumference? What if I didn't have that? So that was 10 pi. What if instead I had 90 degrees here and I had here? That'd be 5 pi because now it's a fourth of that circle, right? The whole circle had 20 pi. That's 4 pieces of the circle, right? If I drew in this, I'd have 1, 2, 3, 4. And so I take that whole circumference and I divide by 4 and I get 5 pi. Do we understand this concept? It's really not a hard concept. All right, here's where the curveball comes in. Are you ready for it? What if I had 50 degrees here and I asked for this length here? Ah, Jacob Sager, I'm impressed. 50 out of 360. Do we see this? Why? Because that's the fraction of the circle we have. We have 50 degrees out of the entire circle has 360 degrees. So we have 50 3/60th of the circle. That's the fraction we have. Multiplied by our circumference, which is 20 pi. That gives us our length. Okay, that's the way I want you to think about these arc length problems. So in this definition, it talks about a ratio. You can do a ratio, but it's much easier to think about the fraction of the circle that you have. You're like, oh, I have 50 degrees out of 360 degrees. I have 50 out of 360 of that circle. Okay, so that's what we're going to do. So it says the arc length of a semicircle is half the circumference. And then for a 90 degree, that's 1/4 of the circumference. So number 1, it says find the length of each arc. So if I have 80 degrees, trying to find the length from A to B. I have 80 degrees out of a total of 360 degrees. And my circumference is 2 times pi times 6. Right? That's all I'm going to do. Now, I kind of just do this all on my calculator. Like I would do 80 divided by 360, and I'd multiply by 2 and then times 6, but I kind of leave the pi off to the side. Because if I put pi in, I'm not going to be able to change it to a fraction, which I kind of like changing it to a fraction. So when I reduce all of this down, I get 8/3 pi. Do you guys see how I did that? So you can do math 1 to get your fraction. That's going to be the length. So L for length. All right, there's no nice way of writing length, arc length. So what I typically write out is length of AB is 8/3 pi. And you could multiply the pi in. If you do, you get like 8.378 as a decimal. Okay, so the next one, go ahead and try it. See if you can reduce it down to. Okay, anybody have any guesses? Very close. It's actually 40 over 9 pi, I think. Is it 40 over 9 pi? Did I do something wrong? Did you do 4 squared is 8 instead of 4 squared is 16?
Oh, I didn't do squared.
All right, so yeah, it should be 40. Oh, why did I do squared? Never mind. You're right. Because it's arc length. I'm getting ready to talk about area. So pi and then 2 pi r, right? So 2 pi r is 4. So what'd you get? 20 over 9 pi. Did you guys all get that? Yeah? Yeah, that's right. I messed up. All right, so my length then, we would say length of arc CD. So we do an arc with a little thing over it, equals 20 over 9 pi. Does everybody see how to reduce your fraction out? So you could do it by hand. Like you could say, oh, divide by 10, divide by 10. 10 over 36 would be 5 over 18. And then multiply by 8. And then you can reduce out. But it's so nice to have a calculator that does that for you. So it's really nice to learn the fraction buttons on your calculator. So if you have a weird calculator and you need help with that, I can help you. All right, so now this is going the opposite direction. So now we have the arc length. And we want to find the circumference. So we say, well, our length is equal to our 72 over 360 times our circumference, which is 2 pi r. Well, let's just write circumference then, because that's what I'm trying to find, right? So my length was that 4.6. So I'm going to multiply that 360 over, and then I'm going to divide by 72 to get my circumference. So you guys see how I did that? I multiply the 360 over first. So 4.6 times 360 on my calculator. And then I take that answer and I divide by 72. So I get 23 is my circumference. That's it. You stop there. So you don't have to write like 2 pi r because I didn't ask what the radius was. I just wanted what the whole circumference was. Okay, my arc got moved. This should say measure of arc CD. When you see measure of arc CD, this is an angle measure. Or really an arc measure, but it's like an angle measure. So I'm going to have something in degrees. Okay, so do you guys see the difference between an M out front and like length of CD? Okay, so we're trying to find how many degrees this is in here. So we're going to set it up and we're going to have, well, our arc length 30 is equal to our degrees. So you can put x over 360 times our circumference, which is 2 times pi times 18. So that's our formula. Then we solve it out. So I'm going to multiply the 360 over. And I have x times 2 pi times 18 then. So I took that 360 and multiplied it over. And the 2 and 18 make 36, so 36 pi times x. So I do that 10,800 divided by 36, and I get 300 equals pi times x. And now I divide by that pi. I could have done that in one step too. So 300 over pi equals x. That is a really weird degree, but that's an answer. So you could say 300 over pi degrees. Right? We usually don't write that. So that in that case, I would probably get a decimal. So I would take 300 and divide by pi using the pi button on my calculator. And you'd get x equals 95.493 degrees. Okay, does this make sense? Do you guys get arc length? It's not too bad. All right, so there's lots of things that you can do with these, like applications. So this one says tires from 2 different bicycles are shown. So how many revolutions does each tire make while traveling 25 meters? Okay, so imagine the tire has a bunch of paint on it, so like yellow paint on it, and it's riding down the road. What we're saying is how many times does it go around in order to make a 25 meters? So it's going like, you know, this tire is moving, 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 and as it goes, it's going to paint on the road. Do you guys know what I'm saying? Okay, so each of these like marks that I have is one circumference. So we're saying how many circumferences fit inside the 25 meters. Do you guys see what we're saying? Okay. So this first bike has 72 centimeters across like the spoke area, and then the tire part adds another 4 centimeters around, okay? So what's the radius of this whole thing going out to there? Yeah, so how do you do that? So we did 36. Actually, it's not 40. Oh, yeah, it is 40. 36 plus 4, right? Does that make sense? We took half of 72 and got 36. And then this width here was 4, which goes all the way around. So this is 4 as well. You guys see it? All right, how about the next one? 31 plus 3. So we got 34. So the circumference of the first one, I don't know why I found the radius. I could have just used the diameter, right? The circumference of the first one is 2 times pi times 40, which is 80 pi. And the circumference of the other one is 2 times pi times 34, which is 68 pi. So we want to know how many revolutions each one makes while traveling that 25 meters. So the number of revolutions for number 1, I'm going to write that in a weird way. How do I find it? What do I do? How do I find how many revolutions it makes? How many times it goes around? Divide by 25? Close. Not divide by 25 though. We take that length, which was the total length was 25, and we want to find how many times a circumference goes into it. Okay, does that make sense in the picture? So we have a total of 25 meters. We want to find how many of these C's fit inside of it. So we're taking our 25 meters and we're dividing by the circumference. Well, our circumference of the first one was 80 pi. Oops. So be careful when you put this in again. You have to put, when you have 80 pi, you have to put that in parentheses because otherwise it's going to divide your answer by 80 and then take that whole result and multiply by pi. It does order of operations. So we want 25 divided by parentheses 80 pi. I have something weird, hang on. Oh, man, I'm not thinking through on this. Okay, I got something weird. Did you guys get something weird? And I was like, wait, something has to be wrong. I got 0.099, and I was like, it's not making like 0 revolutions. So what am I doing wrong? Mr. Crawley would be so mad at me. No, I'm centimeters and meters. I gotta have the same units. So if I have 25 meters, how many centimeters is that? Close. 2,500 centimeters. So I'm gonna do 2,500 divided by 85. And I think that will make more sense. So it's going to make a total of 9.947 revolutions. So the number of revolutions for number 2, for the second bike tire. I take my 2,500 divided by my 68 pi. How many revolutions did this one make? Yep, 11.703 revolutions, so a little bit more. All right, does it make sense that the smaller tire, sorry, I have to sneeze, would have more revolutions? Excuse me. Yeah, because it's whipping around faster. Well, it has to, I don't know. It makes more revolutions to cover the same. It's like when I walk down the hallway with someone that's really short, Mr. Morrison, and I make twice as many steps. So Mr. Morrison was walking by me one day, and I was like, oh my gosh, look at you are so fast. And he was like, I had to. When I was growing up, I had to keep up with the kids in my neighborhood. And he just walks super fast, if you've ever walked next to him. So it's like just the same concept. All right, so this one. So in the Little 500 bike race in Bloomington, have you guys heard of the Little 500? No? You never have? All right, riders complete 200 laps on a fourth of a mile track. Suppose the men's tires are 70 centimeters with tires in diameter. How many revolutions does each tire make? So this is a tricky problem because we have everything. So we have miles and then we have centimeters. And we would need to change everything into inches. They'd all need to be the same units. Do you guys know how to do conversions? Have you done this in science class yet? So let's start with a 1/4 of a mile track and 200 laps on it. How many miles am I going? Total. Yeah, 50 miles. When you do a conversion, it's like one big fraction problem. Okay, so you'll be doing this in your science classes. Sorry. So I'm going to put miles on the bottom. And I'm going to put feet on top. And I want it to be like I'm multiplying by 1, like the same thing over itself. So I gave you a conversion. I said there's 5280 feet in 1 mile. So when we do that, the miles go away. So right now we have 50 times 5280. So we're like, oh, in those 50 miles, there's really 264,000 feet. But I want to go further. I want to go to inches. So I have to go one more time. So how do I convert feet to inches? Yeah, there's 12 inches in 1 foot, right? So now my feet cancel, and I'm left with inches. So I take that answer and I multiply by 12. So I got 3,168,000 inches. That's a lot of inches in this race. So now we have our 70 centimeters in diameter. So what's our circumference? 70 pi, right? Centimeters. So I want to change that 70 pi centimeters into inches as well. So if I'm changing that, I gave a conversion. I said there's 2.5 centimeters in 1 inch. So we say 2.54 on the bottom, 1 inch on the top. Right, because this is like multiplied by 1. It's something over itself. These are the same measurement, right? 1 inch is the same as 2.54 centimeters. But what that allows us to do is we can cancel our units. Centimeters on top cancels with centimeters on the bottom. So now we're left with inches. So I'm going to take 70 pi, and I divide by 2.54. So when I do, I get 86.579 inches. So last thing, so it says, well, how many revolutions do the tires make? So how many times does that tire go around? So we take our total distance and we see how many circumferences fit inside of it. So we divide it out. The number of revolutions is more than 36,000. That's a lot. Okay, does that make sense how we do that? Tricky. Yeah.
Where did you get the 86
I took 70 times pi. Did you do the pi as well?
Yeah.
So I got 219, and then I divided by 2.54.
Oh, I did times 2.54.
Yeah, you got divided. So basically, this one goes on the bottom because of the centimeters and centimeters need to cancel. And that's why we do this. This is called dimensional analysis or unit conversions. Or I think in chemistry they call it stoichiometry. Have you guys heard of that? But basically it's like putting units on top, units on bottom so they cancel. So if you have miles on top, on the next step you want miles on the bottom to go away. So it's kind of tricky. All right.